Okay, this is our last page, page 4. Walk through some of these with me real quick, and we'll go through some of these as examples. All right, so this first one right here, I like to circle this whole piece right here, and I go multiply once, multiply twice. That's the first thing I do, and then I rewrite it. So I'm going to rewrite 3x because nothing changed about that. And then I go negative 7x, and then I go negative 7 multiplied by 3. And if I did that kind of off to the side, it would look like this, multiplied by 3. And I would have rewrite it as negative 21. Okay, then I go less than negative 13. And again, we sort of like to put a line straight down. That helps out, I think, quite a bit in keeping yourself organized. Where are my two sides at? That kind of thing. So this one right here is an x. It's on the same side as this one. So all we're going to do is put those two together. All right, so I combine those. 3 minus 7 is negative 4x. Use a calculator on your arithmetic if you're making mistakes, and that is totally okay during the test tomorrow. Negative 13 as well, and so right here I would undo stuff on one side. I don't have any more combining like terms, but I do add 21 to both sides, right, like this. Add 21 to both sides. So I have 21, and I should get an 8 out of that on that side. This side right here will cross out. My inequality is facing the same way, negative 4x, and I get an 8 right here, all right? And so this is going to be dividing by negative 4 is our next step here. Divide by negative 4 and divide by negative 4. Ooh, do you see what I just did? I divided by a negative. If you divide by a negative, then in part of your undoing process, then you need to take the inequality and flip it around. These will cancel out. And so instead of saying x is less than, I'm going to say x is greater than, not 8, but negative 2. All right, scribble that out. Here, let's go like this. X is greater than negative 2, right like that. Okay, so go graph it. Now it's going to have, this is my answer, but it also asks you to graph it and represent it in interval notation. Okay, so x is going to be greater than negative 2. Where's negative 2? Open circle on negative 2, right like that. It's going to be greater than, so I shade it this way, right like this. And make it nice and bold, make it nice and pronounced so that we can see it. And your interval notation will say, use a parenthesis, call it negative 2, comma, infinity, positive infinity, end parenthesis. And remember when we use parentheses versus brackets. Parentheses are for when it's open circle or not including that number, and we use brackets when it's actually including that number. And we say from what number to what number, and it's going to go to infinity. All right, let's keep going. Let's solve number 2 right here. And we're going to undo stuff so that our x's get on one side together and clump together. So you can do it in a lot of different orders here. Maybe I'll do plus 2x to keep it all positive. Plus 2x right there. All right, so I'll cross these out. We get 6 on this side, greater than or equal to. And 3 plus 2 is 5x minus 34. Now the next step I do is I undo the minus 34. So I'm going to add 34 to both sides. Add 34 to here as well. And remember, here are my sides that we're talking about. Okay, so we cross these out, and I drop down 5x. My inequality is facing the same way still. And I go 34 plus 6 makes a 40. All right, divide by 5. Divide by 5. I did not divide by a negative, so I keep the inequality facing the same way. And so my final answer, these will cross out, and my final answer is x is less than or equal to 40 divided by 5, and that would be 8. All right. Okay, so we'll go graph it. And the next thing is to graph it and make a nice solid dot on 8. Fill it in, and I filled it in because of the that inequality right there is equal to. And then I'm going to shade it less than, because the way I read this is I say x or all numbers that are less than 8 because of the pointy part on it and where it's pointing. Or you can think about the alligator mouth, which number it's chomping. All right, this is pretty sloppy because it's hard to draw on this thing, but you get the idea, shading it this way. All right, interval notation is to go from 8 to negative infinity. all right? And it will be n parentheses right like that. But wait, hold on. Did I do something wrong? It's not parentheses right here. What is it? On interval notation, it will be a bracket, okay? So go back and make that a bracket because it's a solid filled in dot right there. Okay, we use a bracket instead. All right, let's go move down and get to those next problems here. Let's go to number 3 and 4, compound inequalities. We spent a little bit of time on this. This is an OR inequality right here. You can tell it says OR right there. So we solve each one independently. Follow your steps. The first step is to solve them. So you go -5, -5, and sort of there's two sides on this one, right? So sometimes you can put that little mark on there like that, and it keeps you squared away. And so we're going to go like this and cross these out. We get 3x is less than, and this would be 11. So we're going to go divide by 3, and what we get left over is x is less than, and we take 11, divide by 3, and we get a 3.6 repeating. And that's okay, no big deal. Okay, what about this one? Solve it. I'm going to do this one in a little different color so that we can just see it differently here. Okay, we're going to go add 8 both sides. And so we're going to get -5x left over here. -5x is less than or equal to, these will cross out. And then I get -13 plus 8 will be -5, and divide by -5, and divide by -5. And I cross these out, and x is going to be less than or equal to, and this will be a 1. Oh, wait, hold on a second here. I just divided by a negative, didn't I? So you got to keep that in mind. Always remember, don't go too fast. If you divide by a negative, then what do you have to do to the inequality? X is greater than or equal to 1. So I got to flip the inequality around the other way. What do I put in between these two answers? Put an or in between them. So it would be this way, less than or greater than, okay? And so at this point, we just graph those now. And so it'll be x is greater than 1. So where do we find 1? 1 is right here. And I'm going to solid fill it in. And then my other one is less than 3.6. And 3.6 will be somewhere just shy of 4. But it will be open on this one. But you notice that our OR statement actually could change. It actually could change into an AND statement based on the fact that we flipped this particular inequality around the other way, and that's no big deal. So right here, what I'm actually going to do is this one will be shading less than this way, and this one over here will be shading greater than. So sort of interesting. And so what we actually get is the shaded region in between them is actually going to be more of an AND inequality. So you can scribble that out and just write AND. Technically, if you wrote this down and you wrote this down and you just kind of graphed it like that, I would take it. That's perfect. All right. So right here, our inequality will be bracket 3.6 repeating and comma 4. Wait, a 1. Wait, hold on. That's at a 1. My bad. Oh, hold on. Bracket at a 1, comma 3.6. And the 3.6 repeating is not including that one right there. All right. So with that said, let's move to this next one. This next one, we're going to solve both of them at the same time. This is starting out as an AND inequality, and we're going to solve both of them at the same time. And so we're going to start undoing stuff, -1. But whatever I do to the middle, I have to do to both of the ends, right? Like this and this, okay? So these will cross out, and I get 2x is greater than 2, and I'll get it less than, and we subtract 1, and it would be 12. All right, so the next step is to divide the middle here, divide by 2. But what if I do the middle, I need to do on both of the ending pieces, right, like this. Because technically I'm solving two inequalities at the same time. So this will cross out, and I get x left over in the middle, which was our goal. Keep your inequalities facing the same way. And this would be 2 divided by 2 is 1. 12 divided by 2 is 6. All right, so it's less than 6, open circle. and it is greater than 1 open circle. And so we shade in between them. This is an and. Now, I should have looked just a little bit closer, because on number 3 right here, I don't really like that throws you for a curveball. It comes out as a decimal. You sort of second guess that, and it turns into an interval where you're shading in between two numbers because it flips around. So sometimes that does happen. Okay, let's go ahead and look at our next problem, number 5 and number 6. Scroll down here, and absolute value. These are our last 2 questions that we have here. Absolute value inequalities. Remember, you got to split them. Then after you split it, you will solve 2 separate inequalities and get 2 separate answers. So technically, when you get 2 separate answers, it's actually a compound inequality, because it's got 2 inequalities that we're representing together. So let's just go through these, number 5, number 6, just really quickly. We're trying to get, first step, remember, is get the absolute value all by itself. Well, this one already is. So then the next step is to split it. So I'm going to go split it here, and I'm going to rewrite it. And remember, keep it, switch. That's keep it, and then switch is a good way to remember this. Okay, so we go x minus 3 is less than 5. Keep it the same. That's the first part of this. Okay, then switch means when you rewrite it the second time, you're going to rewrite the first and switch the inequality, make it face the other way, and switch the 5 to a negative 5. That's the 2 things that we have to do there. All right. And so with that said, we're going to start solving each of these. So we're going to add 3, both sides, right, like that. Then we cross these out, and we get x is less than, and it looks like it'll be less than 8. Right here, we're going to add 3 to both sides, same as the other one. We're solving for x, trying to get x by itself. So x is going to be greater than, notice the inequality is a little different, and it will be negative 2 on this one. All right, so go graph it. All right, what do I write in between it? Let's not write and or yet. Let's go graph it first and see what happens. Okay, we're going to have an open circle at 8. Graphing that first one. That one will be less than. So I could start thinking about what direction it's going to go. All right, and I could start shading it that way just a little bit. And then x is greater than negative 2, so sort of like this, and it will be greater than. It looks like it will be shaded in between these two, right? And so it will sort of look just like this in between these two, because this one goes this way and this one goes this way, and it'll be shaded towards each other. And we want both of these to be the same x, so it's the same value, and so we write an and inequality in between there. Or we could represent it like this: less than 8, greater than negative 2, just like that. That could be our final answer. Or you could write your final answer this way: interval notation, negative 2, comma 8, because it's not including negative 2 and not including 8, so we use parentheses. All right, let's look at this one, number 6. The goofy part about number 6 is that you got to get the absolute value. Look at your notes. Look at the steps associated a little bit. And it will be negative. You got to get the absolute value, first step, absolute value by itself. So we add 13 to both sides. And by sides, remember, sometimes it's helpful to, put a little line down on that right there. And so we're going to add 13 to both sides. Okay, these cross out, so I have absolute value of 7x. Keep your absolute value right now. We're not splitting it quite yet. And you're going to say greater than or equal to 13 plus 22. And you're going to take those two right there and add them together. And you get 35. And so right here, we're going to go 35. Now that my absolute value is by itself on one side, now I'm going to split it. Okay. And the first way I write it, keep it the same, exactly the same, with the inequality facing the same way. Everything about it is exactly the same. Now, when I write it over here, I'm going to write it a little differently. I'm going to write 7x and then switch, which means switch the inequality, switch it to a negative. All right. That's the idea when we're solving these ones. Okay, now I'm going to solve and get 2 answers, get 2 possible answers. And so right here, divide by 7, and I get x is greater than or equal to, and it looks like 35 divided by 7 is going to be 5. So I write down 5, and now I solve this one. Divide by 7. Divide by 7. These cross out right here. And I get x is less than or equal to, and it will be negative 5. All right. So sometimes it works out that way, and sometimes it doesn't. Where they're 5 and negative 5, right? But look at the inequality. It's facing the other way. So I'm going to go to 5 and make it solid and filled in. Circle right on top of 5. Where is that? Right there. Okay. And then I'm going to go solid and filled in because of this little equal to mark on it at negative 5. Negative 5 is located right there. Okay, right here it says greater than or equal to 5. So greater than or equal to 5 means shade this way, right, like that. All right, shade it that way. Now this one says less than or equal to negative 5, which means shade it this way. All right. And my interval notation on this one, this is an or inequality. So technically that's my answer if I read a little or in between, because x can't be in two places at one time, and it's either greater than this value or less than this value. And so it's either above or below, but not in between. Okay, so we're going to write negative infinity for all the way to negative infinity to negative 5, including negative 5. So I use a bracket. Okay, and then I write or in between these, and I'm going to write bracket 5, because it's going to be from 5, positive 5, all the way to positive infinity, right, like that. And so that's what my interval notation on that one would look like. All right, there will be a very simple one of these on the actual test tomorrow. All right, keep up the hard work, and remember, like always, fast forward, rewind, in order to go over each individual problem.